Here we have Ali Farhadi, we have Luke Zettlemoyer, and Brian Raymond. Guys, thanks so much for joining. This is going to be a really fun conversation. You know, each of you operates at a different intersection of AI research and the practical application of that. And maybe just to make it real for the audience, can you talk about what you've seen in the past 12 months that kind of underscores how fast research is turning into something practical and applied?
Do you want to start? First of all, great to be here. Good to meet you all. I think one data point that I could actually share is how fast models from the release dates are available on these platforms. These days, when you put a model out, typically you have it been served in the standard platforms the day before. So this is how fast things are evolving in AI land. You mentioned the fact that we actually see papers being discussed at investment platforms 48 hours after the paper being released in the archive. And it's day and night, I think. Luke and I have seen papers being sort of going through the review cycles. You don't hear about anything for 3 months. Once they're published, they slowly ramp up. Even some of our most successful papers had that flavor that it took a community almost 6 to 9 months to get noticed. And now it's just, we're talking about hours. So I think that's phenomenal. What comes with it is also the struggle that I think many of us have. I'm curious to see how others think, is sifting through the noise. There used to be a time where we could actually claim that we're aware of papers in archive on that week. Now there are 6,000 papers a day on archive, at least on our side of the board. Of course, many of them are not worth reading or not worth spending time, but just sifting through that noise is also a struggle for many of us.
Yeah. Also, it's really wonderful to be here. Thank you, John. It's just crazy, the pace. And so now what I tell folks is like, you got a result, just get it out. Like, you know, do a good job, make sure the science is solid, and just get it out, and people will be using it kind of instantly. And then I think part of also is kind of about like what new things we're seeing happening and so forth, not just the pace of it. And I think to a first approximation, like up until this year, we were largely seeing kind of text-based interactions. We've all kind of chatted with the bots, but now that's all changing. Like the sort of agents are hooking up to everything, they're interfacing with everything, they're all multimodal, they're sort of becoming much more integrated and not so isolated only in the text interactions. And it's kind of fascinating to see where that's going. And those things are happening like lightning pace. And I'll just say, you know, it's both exciting and frustrating as a researcher. So I've had, you know, projects at Meta that we're heavily invested in, and then halfway through, you know, Gemini lands and it's multimodal and we were supposed to be first and everybody freaks out. So, you know, it's fine, but that's the world we live in. And, you know, you get into it and you enjoy the competition, but it's a whole different thing now than it used to be.
Luke, can I ask you to take us to the moment where the DeepSeek most recent paper was released, and how at Meta the teams tried to tear that down and understand it and put it to work quickly?
Yeah, the DeepSeek, I think, it definitely took a lot of folks by surprise, there's no question. And in particular, it also embraced kind of the open source ethos, which I think AI2 deserves a lot of credit for, but also Meta deserves some. Not fully open, but like relatively pushing the open agenda. And so not only was it kind of a breakthrough, and not only was it a lot more efficient, but it was available. It was like in your hands right now. That's the pace of things, right? Like in some sense, if it's not available right now, you don't even necessarily trust it. You don't look at it. You like move on to the next thing. In terms of the technical breakthroughs of DeepSeek, I think the jury's still a little bit out. You know, it's hard like to replicate that training even at that scale. I think the marketing was. Marketing is good, but it was clever marketing, and you know the numbers you saw quoted for how much it cost to train, that wasn't the whole life cycle of development, right? And the whole life cycle of development is a very significantly larger number, like $1 billion plus at least. Who knows exactly what it is? But nonetheless, it was still a huge advance and a big deal. And you know, you could imagine. I won't comment too much specifically on Meta, but any company that's trying to do open sourcing. And has a lot of resources, and then another company comes along and open sources something using a lot less resources, that's going to be a wake-up call for you. And yeah, that definitely happened.
Got it. Brian, what do you think?
Look, I think over the past 3 years, there's been this like enormous like pressure on companies to fuse their data and organizations with these models. And over the past 12 months in particular, we've seen a huge leap forward in the mechanisms that are being used to fuse that data with models. On the one hand, we've seen rapid development of these kind of multi-step reasoning models, and exemplified by DeepSeek, but pioneered with OpenAI, Anthropic, Meta, and others. And then also this explosion, maybe a little less so from the research community and really in the developer, open source developer world around multi-agent systems. And whereas this was nothing really more than vaporware 18 months ago, it's actually become really practical to build companies around this now. Just over the past 2 weeks, we've seen an explosion of open source developer activity around something that Matt was talking about earlier, model context protocol. And so I think that you'll continue seeing incredible pace of deep of research development that are coming out of Allen Institute, coming out of the labs, that are actually coupled on the kind of the other side of it is this flurry of developer activity, all kind of focused around how do we drive real world value from these tools.
Got it. You know, if I key on the reasoning point that you just raised, I'm interested in this group's opinion about two things. What is the state of reasoning today in terms of what models are really capable of? And where do we expect we're going to be in the next 18 months or so? Start with you again, Ali.
Sure. So I think we see good progress in reasoning. Let me step back and sort of explain how I feel about it. So when you think about reasoning and AI, it's a fairly wide topic.
Yeah.
What we've seen so far in terms of the skills that you could call reasoning, we've seen good progress in showing reasoning capabilities when you narrow down the scope. Either you narrow down the scope by a topic or by a subset of capabilities that you've seen. A good example of that is what we've seen even over the last 10 months in math. If you give me enough samples, if I actually follow a specific recipe, being chain of thought, being description, and use RL techniques that the community knew about for almost a decade.
Reinforcement learning.
Reinforcement learning. You could actually do well on those tests. So great progress in that space. Do I call it reasoning or not? I think we see some levels of reasoning happening. Is that generic enough or general enough that you could actually deploy at a scale? I am not convinced, or we have not yet seen results that convince us. There's also a subtle element here that we need to be aware of is when we talk about reasoning, most of the time is about sort of going beyond the domain within which you train on, because that's where you actually need reasoning. Otherwise, you could have done supervised training. And without knowing how you train a reasoning model, on what data do you train it, what was your approach to the problem, it's hard to argue how much of the stuff that we're seeing today is, for the lack of better word, pattern matching of some form, very sophisticated pattern matching of some form, and how much of it is actually getting out of the way by putting things together. And that's the part that I'm still fishing for some evidence to understand where are we in that spectrum. We as a community, I believe we don't know yet where we are. But we've seen enough evidence that for narrow domains, it's working. Beyond that, I think we need to establish a proper taxonomy. We need to figure out how we're going to evaluate it the minute that you go out of math. There's a reason we all fixated on math. It's a suitable domain. We know how to evaluate it. We know what kind of reasoning tasks are involved. And as we move beyond these, I call it structured domains, to the wild, many of these assumptions will break. Like Luke talked about multimodality. I'm excited about embodiment. And when you start actually moving out of these domains, we actually face a whole different class of reasoning problems, many of which, because it's just so obvious for humans, we might not even have taxonomies for them. And many of them will become big, big problems for us, as we've seen before. Things that are easy for humans are hard for these machinery, for AI. And I expect us seeing some deployments beyond math, and then seeing and struggling in that space, finding another class of solutions. So we're not there yet, in my opinion, in terms of reasoning capabilities.
I see.
But lots of exciting progress so far.
One thing that really strikes me is, you know, when we had this conversation 2 and 3 years ago, we talked about studying AI as a biological organism. You know, how does it behave when we train it under different regimes with different kinds of data? And the language, the taxonomies we use now are different. We talk about them as different levels of student. Is this a middle school or a high school student, or a college or a PhD student or a professional? That's a categorically different question. We may be very far to the left of the human student spectrum, but we're not talking about these as, you know, amoebas anymore. And that's kind of embedded into our assumptions. And even without the answer you just described, there's a lot we don't know. The very question being so different, to me, illustrates how far we've come.
I would just caution people against these comparisons, mainly because in some of these cases we're really good, but in some of these cases we're as dumb as a 6-month-old. Right? We just need to balance these things out.
Yeah.
Yes, if you narrow it down, if you define it, if you give me lots of samples and walk me through this whole process, I could build a really good model for you.
Yeah.
But at the same time, that very good model is going to struggle miserably in some other domains.
Yeah.
That you haven't gone through this.
Yep.
And that, to me, is the hallmark of generalization that we're not seeing yet.
Got it. Brian.
One comment on this is, I think that over the past 12 months, vertical AI, like companies built around vertical solutions, have leapt out to a big lead, or at least have grown at a pace. Like Harvey AI, for example, a legal tech startup, right? Forged a partnership with LexisNexis, and this is to Ali's point, right? And they were able to do incredibly focused training on a very deep pool of legal texts, right? And they were able to package that very narrowly in order to create value, right? And so narrow set of circumstances, deep set of post training, right? And they were able to deliver value there. Now, let's contrast that with like organizations that are producing, you know, hugely disparate data, right? From back office to revenue to R&D, whatever, right? And then they bring these general purpose models on top of them. That's still just a lot harder to squeeze value at this stage. I think that, I mean, Elliot, correct me if I'm wrong, but I think that's kind of what you're getting at, is that if you really, really narrow the data sets and the tasks, you can absolutely dazzle your users, but for more general purpose, it's still a dogfight to get these things into production.
What do you think, Luke?
Yeah, I think I totally agree. And maybe I'll just draw an analogy. I mean, I think lots of patterns can still be really, really useful if we're talking about the impact. So I think it's very exciting. But you know, one analogy, the way I think about these models is like they're compressing, you know, the internet basically. Like they're getting obscene amounts of data that are so big that we can't really even think about it, and they're somehow compressing it and regurgitating it in a way that's, you know, we don't understand as scientists. We need to understand that better. But then if you think about it that way, you know, you talk about the grade level, like across the internet, there are plenty of documents that tell you how to solve elementary school, middle school, high school, and even, you know, law school level problems, right? And it's seen a lot of those documents and it's trained on them and it's compressed it into its parameters. And then the inference scaling that we were talking about, you know, that's sort of when you're using the model, it's sort of, instead of just answering the question, it gets to generate a whole document and then answer the question. So it actually just kind of gives it ability to recreate something that looks like maybe a study guide it saw in its training data or some other reasoning example it saw in its training data. Now, we know it does generalize some from its training data, right? So we know it's not just exactly copying things that it's seen, but sort of the science of understanding how far it actually moves from what it's seen before and how close it is and exactly whether it's in the narrow domain or whether it's gone to a more general domain. You know, everything's moving so fast. And the experiments to study it are literally like, you know, tens of millions of dollars to run. So it's just a very tricky space to be in right now. But it's very exciting and it's fun to think about. And, you know, even if you are just regurgitating that much data, that's still a very powerful thing to be able to do. But let's not think of it as like, you know, I think there's no examples I know of like real novel explorations, like inventing new things that really, then it's not going to open up a whole new field of science. It's not going to like, you know, write a Pulitzer-winning news article. Right? We're just very, very far from like real new reasoning and inference like that.
You know, on this theme, Luke, can you talk about the insight of the S1 paper that you co-authored? Because there's a lot to learn from it, I think.
Yeah, so we had so the inference scaling in general is this idea that, you know, when you're trying to solve a problem, then it can say, let me think about this. And then it can think for a while. It can sort of say, oh, maybe this is true. No, that's not quite right. And then it needs to reflect or whatever. And so lots of people have done very complicated methods for making models be able to do this long sort of internal monologue, chain of thought reasoning before it answers a problem. And so, as a scientist, I like to try to break things down and try to simplify. And so the idea behind the project was, what's the simplest possible way to get a model to do that? And the hypothesis was that the models probably already know how to do it. It's probably in the training data somewhere, but it's so rare that they just don't do it by default. And you just need to kind of teach them to trigger that behavior that they've already memorized from the internet. But it was such a tiny fraction of the internet that that it doesn't do it automatically. And there's lots of evidence that that's kind of how models work, that you need to kind of pull out things they've already learned after you train them. And so we did that. So we got just a few, about 1,000 examples of this kind of output that you'd like the model to have, tuned it a little bit to do that. And then there was one other trick, like if it stopped too soon and you wanted it to keep generating, you would just put in the word wait. And then you'd ask it to continue generating from there. And it would just it'd be as if it asked itself, like, wait, is that right? What's going on here? And that's it. That's the whole trick. Like a tiny, tiny tuning, very little compute applied, and a little prompting trick. We all know about prompting, right? A little prompting trick to get it to keep going. And then you got the similar scaling trends. You got numbers that are almost as good as other things. And so for me, the result was really fun because it's practical, it works, it's simple, but also because it's kind of reconfirming this idea that it's really about the compression of the original data. There's not something magical going on. That's satisfying to me as a scientist and how I think about things.
I think we can all reason better by telling ourselves to wait.
I should do that before I answer your question, but yeah.
So Brian, you're building infrastructure that helps enterprises transform messy data into structured data for better decision making. And you're a customer of all this research that's happening. Yeah. So, as a loud customer with a couple of eminent researchers here, what are some of the breakthroughs that you would like the field to produce to make your job easier?
Look, I'll celebrate one big one over the past 12 months that's made a huge impact on in our neck of the woods, are vision language models, image to text models. So you feed in an image, spits out text on the other side. The performance of these were very spotty. The compute required for inference was enormous. The latency was long pre-2024, but over the past 12 months, the door's been blown open on this, and it's unlocked huge amounts of value. And this kind of gets to what Luke was talking about with the rise of these multimodal models, where you put it in one modality, spits it out in potentially a different modality. This for us, the promise that we're making to our customers is that you can feed in. It's like a wood chipper, right? It's like the least sexy thing in the world. You jam in anything you want, out pops data that is readily interpretable by a foundation model, right? And so if you're an organization, you can feed in everything, whether or not it's audio or image or video or PowerPoints, whatever it might be, and you can create a Gen AI data layer. Well, it's actually in practice really, really tricky to do that. We support about 65 different file types, but even different document layouts are tricky, or which version of a PDF is tricky, right? And so with the development of these higher-end models, especially like Gemini Flash came out a couple months ago, where the compute required is drastically lower. And so, for example, like
Gemini Flash is a light model from Google.
Is a light model from Google that does this, where from a business perspective, we're talking with a large mortgage company. They're spending right now around $5 million a year for OCRing documents, and this will drop it down below $100K a year. And so this isn't really a result of us. We're packaging up, we're orchestrating it, but this is sort of the synergy between us, where we're sort of on the last mile, packaging it into infrastructure for organizations, but really benefiting from huge leap forwards in the quality of the models that are available in the market.
Yeah, I think there's going to be more soon too. Yeah.
Just a good guess. Just a guess.
I have no idea about any projects at all.
Yeah. So, Luke and Ali, you mentioned the concept of open source AI. And that's something that's, we've all spoken about for years, and it's really caught a lot of attention from enterprises. And one of the promises of open source AI is that these weights are accessible. The weights are like the source code, of course, of a model. And as a customer, I can choose to train or tune this model myself. And yet, there's always been a question on my mind: how many enterprises and how many app developers are really going to do that, practically speaking? And if we assume that plenty of enterprises and plenty of app developers won't, why is open source AI so exciting still to them?
Well, let me start by questioning the premise. So in this very room, if I'm not mistaken, 3 years ago, maybe 2 years ago, Matt was on stage and he was talking about the fact that there is no one single model that serves it all. I still believe that is truly the case. I believe these models are extremely powerful. They are very capable. They are great demoers as is out of the box. But if you actually want to deploy them in practice, you got to tune them somehow. The key power of these models.
Me as an enterprise. Me as an enterprise.
Yes. Okay. And I think there's a lot involved in tuning these models. And there are different levels of tuning that involve. You could actually think that, oh, I could just have an API call to a closed model or say, here's my data, nudge your weights into so that my data becomes in distribution so I could actually start running my algorithms. And we see some progress in that space, and this is sort of a class of usage in enterprise data for those who are comfortable putting their data out. Then there is a class of, let me download a model from one of these open weight models and let me tune it myself. And over the last year, I think one of the things that we're learning as a whole community is how involved tuning is and how much you could actually squeeze out of post-training to make your models significantly better in your domain. This is not just us. I think there's a wide array of developers out there, researchers who are also discovering this together, that you can get a lot out of tuning. To the extent that now the boundaries between pre-training and post-training is already very, very diffused, because now you have mid-training and now you don't know where to call I'm done post-training, when to call I'm done mid-training, so therefore you could actually do tuning. So if you put all of these things together, so one of the things that enterprise users are seeing from these open weights model is that they actually struggle to tune them to the extent that they would like to tune them without seeing regression in the behavior of a model somewhere else. And that is a classical example for like a decade-long classical example of all of these models, is that when you nudge them some way, they're going to sort of move the importance of that knowledge, put those more of the emphasis on those set of weights, therefore you're going to lose on some other capability. And the only effective solution that we've seen so far is just mix a little bit of pre-training data while you're doing mid-training, while you're doing post-training, and you see significant improvements. Also at the same time, we see that post-training used to be just a standard supervised training. Get a little bit of your data, let me post-train it, and you're done. But now we're seeing that with RL, with reinforcement learning, with verifiable rewards, with other tricks, inference time involved, the post-training part, the process from which you actually assume that you have a set of weights, they're good, now you want to go solve a problem, this step is actually getting more and more involved. And you squeeze meaningful amount of juice out of this process if you know what you're doing. Without a full transparency of the whole stack, researchers, developers in these enterprises are actually crippled on how much they could actually squeeze out of an already pre-trained model. And that is what we're seeing right now. One of the sort of ginormous players in this space were just pinged us because of that very, very phenomena, that our customers are struggling to tune a specific model because of this limitation that they're observing. What are other solutions out there?
Got it.
So I think that to me is going to be one key piece of the puzzle that open source will play for the enterprise level. But the most important one to us is going to be the research side of things. Luke alluded to the fact that there is so much that we don't know about the behavior of these models. And that would be the building blocks for having the next generation of capable models. And without opening up the whole stack, it's just scientists are crippled on understanding what these models are doing. And the key part of it is just messing with the input-output behaviors to see what we could do.
Yeah.
So there's a lot about customization. I think that is probably the name of the game in the next few months, is how effectively and how efficiently you can actually specialize models to your problem. And there's a problem of data efficiency, there's the problem of parameter efficiency, which alludes to the fact that how much you're going to actually pay for an API or for a GPU compute. And those, unless we're solving them in a more principled way, I think we're going to struggle as a whole community.
Got it. Folks, I think we could keep this going for a really long time. We're out of time, but really enjoyed the conversation. Thank you all so much for the chat. Thanks, everybody.
Thanks, Jon. Appreciate it.